So, excuse me, I told you the first two were going to be increasing, the last two decreasing. I took away number 10, but I didn't say number 10 increasing, decreasing, because it was only a radical, so there was only one arm to it, but we let that go. So increasing, decreasing. I want you to be able to do two things. I want you to be able to show me where this graph is and restrict this so that you're only showing me the part that you need to use. Don't show me this whole part. Don't show me this whole part. This has to get restricted. So when you get down here, you have to restrict this domain. Otherwise, this is a line that comes all the way out, and you don't want that other part of that line. So make sure you restrict this. And again, find your domain and your range from the first one after you restrict it, and interchange them, because that's your rule. These interchange to yx. Therefore, the domains become the range becomes the domain, and you should be good to go in that. If you check, I only checked it one way, but you have to check the other way as well.
What else to check on?
I don't think it says check on it. You could also, I don't think I have a check on it, but you could also graph it and see the graph to make, just to make sure. You could look at your graph. If it's the test, I would definitely do something for a check. I would graph it and just pick a point and interchange it and make sure it's there. That's a good way to check geographically. I don't think I said algebraic check. Questions? It's your review. You tell me.
When you do the inverse of it, like when you're just starting to do it, why don't you have to, like, since it's absolute value, why don't you have to do positive and negative?
Because I'm only going to do one leg of it. Normally an absolute value has a positive and a negative, right? But then that would mean I'm also doing this part. That would give me the negative part. I don't want the negative part. I'm going to only restrict it to the positive part. If we were using the negative part, then we're going to set it equal to the negative.
I know that on that lab that we did, we have those different ways to plug in the calculator.
Yes.
We should do those.
No. I like that. I like that lab only because you get to actually see your calculator does a draw inverse. You could put yours over it. You could always use a solid line, or you could keep the same line and look to make sure your table is the same. But it was a good exercise in playing with the calculator. Yes.
So the inverse is just a line, like I don't know how to stop.
You stop it by doing this. You take your original domain and range. When you get to this, when you graph this, you get this whole thing, right? And we said the domain would be all real numbers of this whole thing, and the range, excuse me, would be from 0 to infinity. Agree? For this whole thing. But we're going to say, get rid of this leg. So now we restricted our domain from only here to here. My range stayed the same. This is your domain, your x values. This is your range, your y values. All you have to do is interchange them. This one will now become a y, so it will now become the range. This one will be, the y will now become the x. It will now become the domain. All you have to do is use your rule of inverse, interchange them. And so all you have to do is put this comma right next to your answer. So that is a line, you're right, but I'm going to restrict it to only go from here to infinity. So I only get that one little piece.
And you said you could do it on the calculator?
You can put this in on your calculator. You can put in the original one and draw an inverse. You can just, even if you just do this one and put this in and then put your new one in, you will see it is a line, but that's okay. All you want to do is make sure that if you pick a point here, say this point, I don't know what this point is, say this point is 2, 4. When you come over here, this point's going to be 4, 2. You just want to check the table.
You can put in like the...
You can restrict your domain.
How do you do that?
You say parentheses, x, then you go to the test. X is greater than or equal to 0. Are you restricting your inverse? Yes. Parentheses, x is greater than or equal to 0. Use the test. And if you don't want to do that, I mean, just put the whole line in. You're really just concentrating, your eyes are concentrating right here And what your goal is, just to make sure that any 2 points, any point I can interchange it and it will be there. That's your rule.
I think we were just talking about like positive and negative.
Yes.
How do you do that again? Like when you write it out?
Okay, so when you do this, you might want to reverse this. Remember when we did our things like this?
Yes.
We said this was a positive. Whatever this is a negative. So you might want to just switch these around. So now when I take this out, this is equal to the positive. If I'm using the decreasing side, I'm going to take it out and set it equal to the negative. And then I'm just going to solve for y.
You said like one way to check was to put that equation and then just inverse and then like you draw inverse to 1.
You can do, I wouldn't even go that far. Like I was just saying to Gabby, if you put this original one in, it's going to look like this, right? Just focus your eyes on this part. Then you know you got that part. If you put this in, it's going to be a line like this. You don't care about this part because you're going to restrict it.
The line I got was like, it doesn't look like it's like a function.
It doesn't look like that's your decrease. That's your decreasing line. You did a decreasing, not an increasing. That actually is the opposite of this. If you pick the point over here, watch. If you pick the point over here, so I'm going to pick negative 6, 9. When I look at 9, I should see negative 6. Yeah, I don't think you're looking at that right. But you also have the decreasing side.
Yeah, we heard it all that.
And I don't either. So this oh, you're looking for this line right here. You got it. Okay, let's watch. Do a zoom 5. So zoom 5 is going to give you more of a square look.
Oh,
So you're technically looking at these ones. Take this point, take any of these points. This is your line. I don't know somehow the other one got rid of it. Take any point over here. Let's go to 4.2. So now if I reverse this, I should see 21.4. And I see 21.4. See it? Yeah. Assume you're looking at this piece and this piece. And another way to do this is go like this. Put this equal to X. It's in the middle. Now just draw your eyes to those two. This one and this one. See it? It made a different line. Yeah, it took the decreasing part. If you did draw inverse on that, it took the decreasing part because it didn't know which part to take, so it took the first part to get off. Yeah. Sometimes your draw inverse, like Anne Marie did the draw inverse, the draw inverse took the decreasing part because it knows this is not a one-to-one. So the first thing that it sees coming from here is this decreasing. So hers gave her the decreasing part on the draw inverse. We can't control what the draw inverse does. So, but what I'm saying is, and when we looked at it, sometimes if it looks better, do a zoom 5 and put your line y equals x in there. You can see a better reflection that way. The zoom 5 takes the distortion out. The zoom 6 is a little bit oblong. Yes. So did you start with this? Was this your original domain and range? So what did you say?
Yeah, I just realized it doesn't make sense.
Are you okay now with it? Okay. Well, you know, don't be afraid to ask any question because they're not silly questions. They're all good questions. They all have good thought in them, and someone else might be thinking the same thing.
Is this test going on in the first quarter?
Yes, this test is going on the first quarter. How bad are these? These are not bad.
It's just the applications is I don't understand.
Yeah, I don't like this. We wrote.
I gave you a huge hint on the application. Huge hint. The one with the fencing is there.
That's
The
hard.
fencing.
It doesn't make sense.
You
You
got
just
me.
do one where it's like this.
That one I can do.
And God bless you. Now, oddly, I find those don't make sense.
Nah, those are like dead.
Well, and algebraically, they're shorter. I realize that. Your windows are smaller. That's probably why you like them better, because of your windows. But they really don't make as much sense as when I minimize a perimeter because I don't want to spend a lot of money on my fence. But I want to maximize my area because that's where my cattle is feeding from.
Okay, I don't know it all.
Oh my goodness. All right, let's get through these and we can spend our time on the applications. So now, this one came from here. This was a parabola, right? And what did your transformation say? Guys, left 3, up 4, left 3, up 4. So you could sketch this piece, right? Now, you want the increasing, so you don't want this. So all I want to see is this piece right here. This is going to help you with your domain and your range, isn't it? So my domain, at my vertex where I cut it, my domain now says from -3 to infinity. And what does my range say? 4 to infinity. So easy for me, when I switch these, when I interchange them for my inverse, these will be my inverse ones. My domain now is going to become my range. My range is going to now become my domain because doesn't all the y's turn to x's? All the x's turn to y's. So my domain now is going to be 4 to infinity. Even without thinking about this, just always put this thing right next to your answer. Even though that's a radical and we don't have to worry about it, because the radical only has one arm to it anyway, just put it there. You'll always be on the safe side. So we start like this. We restricted your domain. Excuse me. We have to solve for y. After we interchange them, we have to solve for our new y. Subtract 4. Now here's the thing. When you take the square root, you get a positive and negative. If I want the increasing, I use the positive. If I want the decreasing, I use the negative. So I want the increasing, so life is simple. Just subtract, and here's your answer. Make sure you put this here, that you show me that's your inverse. And this one doesn't need the restricted domain. Stick it there anyway. It just makes life a little easier. Here's your reflection. I'm going to the right 4, I'm going down 3. I'm going to the right 4, down 3. Another way to do it is always take that vertex point and right away interchange it. And you'll see your reflection. Remember, I need sketches on this. Sketches. Everybody good with that? I think you have a harder time on the absolute values. Nope, you have to write f to the -1. That's our function notation. I don't ever remember seeing a y to the -1. I never. You did it last year like that? That must be a Common Core thing. I don't know. That must be a Common Core because I've never seen that. Okay. These two are decreasing. They work the same exact way. However, when you get down here, watch. You interchange them, right? I'm going to just reflect this. I'm going to put my absolute value on this side because I like my absolute value on my left because I'm always used to seeing this. So I know when I take this out, and always make yourself a small one on top. So now I take this out. I want the negative. So therefore, I'm going to use the negative root. 2y minus 6 is equal to the negative of whatever this thing is. That's it. Then solve. Okay, I'm sorry. If you change the one inside, you have to change both. It has to be both, and not this one. So you have two choices. You either change this one or you change both inside. I don't like to do that because I will tell you why. When you guys learn conjugates, you change the middle sign. So a lot of kids, when they do this, they just change the middle sign. So to avoid that, I always just change this one. That's just me. But if you do that, you change both of these and not this one. And it'll still come out. Now, when you get to this, when you graphed your first one, it looked like this. So you had to restrict your domain to the decreasing side. And I want to see just the restricted part. Here's where you're going to need this. Decrease your domain from -infinity to 3. And you always come out positive. Your range is from 0 to infinity. Make sure you take these and you reverse them for this, because this is a line. That is the equation of a line. So you need to restrict it. God bless you. And you don't have to say restrict it with. All you have to do is say this and give me your new domain. Oh, actually, I only need your domain, but just put your domain and range there. Because this is a continuous line. This line continues. So you say, oops, I only want it from 0 to infinity. That's the only part I want to look at. It's the same absolute value. If you're using an increasing, you have the positive piece, increasing. If you're using a decreasing, you have the negative piece, decreasing.
Isn't the inverse decreasing?
The inverse is, I want the decreasing one.
No, like when you draw it.
Is it going down? Probably it is. Probably it goes down a little bit more. It should. Yes.
For the inverse, I changed the, like I made -2 plus 6.
Okay, that's fine.
When I enter was x minus 6 over -2. And if you had pulled out the negative,
That's as long as you can put the negative anywhere you like.
no, but it's not the same.
It's not the same.
No.
So did you change this negative x as well?
No.
No. So you did this. Negative 2y plus 6 equals x, right? Is that what you did? Let's just separate them. Is that the same as this? Yeah. I just separated it so you could see it better. That's what you have? That's fine. Because watch. If I separate this, this is -1/2 x plus 3. It's the same exact thing. Too many negatives always look a little bit confusing. Just simplify it. Well, you look for the turning point, because your turning point says cut it right here. I only want the decreasing part. Once I turn, I'm going to increase, right? So use your, well, this is 6 divided by 2, but use your concept of, I move it to the right 6 divided by 2. That'll give you this point. But you should probably be able to see that on your calculator. Just do a minimum. That's the point you want, the minimum. There's a number of ways you can do that. Good? Okay. And your last one, everybody okay with this one? Decreasing? I want the decreasing. Remember, start like this. Here's your parabola. I don't want this side. Find me your vertex. This is going to the right 2, up 2. To the right 2, up 2. This is my ending point right here. So my domain is -infinity to 2, and my range is 2 to infinity. Get these first. Then restrict them. Do I have to restrict this? No, because this is a radical, so it is just that little arm that's there. If I turn this around, you can see that you can see there's a reflection, and you can find your vertex. But I would just put those there just to be on the safe side, and then you never have to think, do I need them or not? Just put them there. Off the top of my head, I don't know.
You sure we can't move it to Monday?
Well, I could move it